This curious shiny metal oblong is what industry experts call a hard drive. And if you started out in the PC hobby at any point in the last 5 years or so, there's a strong chance you've never even owned one. This box of spinning platters is what us boomers used to use for storage before the invention of SSDs, and the slow performance and general frustration associated with these drives is one of the reasons why I'm not nostalgic for the 2000s. In the year 2026, there's no good reason why you'd want to use one of these relics of the past as the only storage device in your gaming PC. And yet, despite the existence of vastly superior options, there are a couple of reasons why you might want to buy one anyway. This video was sponsored by Asus Disk Copy, more from them later on. If you haven't had the pleasure of using a hard drive as your primary boot device before, let me take you for a walk down millennial memory lane. Hard drives are essentially boxes containing densely packed spinning metallic discs with a read head, kinda like a gramophone if it was reinvented for the 80s. As impressive and borderline miraculous as it is that this precision technology actually works in the first place, the limitations should be obvious. A tiny motor running at thousands of RPM inside your PC is gonna make some level of noise during operation, whereas SSDs are essentially silent. Hard drives have seek times, which is an extra step in the process of loading data that solid-state media doesn't have to deal with. Moving parts make HDDs less durable, which matters more for laptops and portable devices, but if you move your computer around a lot, then that could be a concern. Hard drives park themselves when not in use, so they take a moment to spin back up to speed sometimes. They suffer from fragmentation when data is deleted, and so on and so forth. In short, it's an awkward hybrid of digital and analog technology from the 20th century that I'd hoped we'd see the back of by now. They have their place, and that place is in a NAS. With all that said, why the hell would you buy one in 2026? Well, as a boot drive, ideally you wouldn't. Solid-state storage has so many advantages over hard drives that they transform the PC user experience, and the downsides of limited capacity and higher cost don't usually outweigh those benefits. Or rather, that had been the case up until recently. SSDs might be non-volatile memory, but their pricing has always been quite the opposite, although they have been mostly trending downwards over the last few years. However, the recent DRAM and NAND shortages have sent SSD prices back up to levels we haven't seen since the 2010s. Hard drives have likewise gone up in price, so it's not like these things are actually a bargain, but it's one way to cut costs in an ever more expensive hobby. For the purposes of this video, I wanted to remind myself, and possibly inform some of you who never got to experience the hard drive days, just what it's like, whether the downgrade from SSD to HDD has an impact on gaming performance, and ask if the cost savings are worth the headaches. Speaking of headaches, I started my journey back through time with my Ryzen 5 7500F test rig with 32GB of, let's not talk about that, and an RTX 5060. The hard drive in question is a 2TB Seagate Barracuda, which spins at up to 7200 RPM. This is higher than average, with 5400 and 5900 RPM being the most common drive speeds, and 10K plus being top of the stack, but also mostly obsolete in the SSD era. It connects over SATA, or SATA if you're nasty, and while that is a theoretical bottleneck to bandwidth, in reality the drive itself is the speed limit. My point of comparison is a Lexar Aries Pro Gen 5 NVMe SSD, which costs about 2.5 times as much as the hard drive and has transfer speeds around 60 times higher. When I put it that way, the SSD does sound like a better buy, but put in terms of actual money spent, wouldn't you rather save $100 or more if you could? Firstly, the new install experience in Windows 11 was quite something. Going from hitting the power switch for the first time to landing on an active desktop took about 40 minutes, but that was far from the end of it. Windows Update had its wicked way with my poor hard drive for the next half hour or so until everything was patched, and multiple system reboots were required to get all these updates properly installed, with each reboot taking several minutes. After everything I needed was installed and updated, and the hard drive had a chance to settle down, I started testing some games. I'll come back to the benchmarking results later on, but the first thing that needs to be talked about is loading times. As you've probably gathered by now, this is something hard drive owners are gonna have to get used to. Modern games are big, levels take a while to load, and even reloading a save can be a painful experience. The longer it takes a Crimson Desert save game to load, the longer you have to ponder why it is exactly that Cliff appears to be walking through the Animus from Assassin's Creed. Load times are not the only consequence of slow storage, however. During cutscenes, Resident Evil Requiem occasionally suffers a very brief audio cutout before carrying on as normal, leaving the sound slightly desynchronized from the video.
Grace, I won't force you to go. But do you think you can do this for me?
Spider-Man 2 isn't the smoothest experience on any PC, but it stutters more frequently and more severely than I'm used to, at least during the first run. It seems to get better after reloading. Crimson Desert is notorious for its short draw distances on debris and high-res shadow maps, but with the hard drive that extends to NPCs, who at least have the decency to fade rather than pop into existence. In the city of Baldur's Gate, it takes a disconcertingly long time for a lot of buildings and landscape assets to spawn when you first load your BG3 save. This isn't at all surprising behaviour in modern games. For quite a long time now, having an SSD has been considered a minimum system requirement by game developers, so running a game from a hard drive is like trying to use a weaker CPU or GPU than the devs recommend. You can try if you like, it might even work, but it could have unforeseen consequences. Having gathered my benchmarks and captured the hard drive gaming experience, it was time to directly compare to an SSD, and that involved cloning my drive using this video's sponsor, Asus Disk Copy. Asus makes it extremely easy to create a perfect copy of a drive, handling stuff like mismatched volume capacities effortlessly. Literally, the 2TB SSD has a tiny amount more available storage than the 2TB hard drive, but I didn't have to do anything to resolve that. Disk Copy just defaulted to extending the partition to fill the available space. I connected my SSD using a USB-C housing for convenience, and the software had no problem with it. I just clicked the button, went for lunch, and when I came back it had made a perfect copy of my hard drive on the SSD. All I then needed to do was detach the hard drive and stick the NVMe drive in my motherboard's M.2 slot, and the system booted as normal, though, of course, much faster. If you need to migrate your PC to a new drive but aren't particularly savvy about the ins and outs of disk management, this is as simple as it gets. No need to reinstall your operating system or programs, and if there's a fault with your existing drive, it will automatically skip bad sectors. Check out the limited free trial, buy the full version outright, or as a monthly or annual subscription at the link below. After booting into the cloned SSD, the OS is usable basically straight away. No more long waits for the hard drive to drop below 100% usage before you can do anything. Load screens are shorter, food tastes better, sunsets are more colourful, woodland creatures gather around you, and all the aforementioned glitches are gone. Even a few hours of using a hard drive as my only storage medium reminded me of the first time I bought an SSD back in the late 2000s, and how the sheer relief of that upgrade made me feel like the world was gonna be alright. In fact, that's probably a pretty solid explanation for the general global optimism of the early 2010s. The economy might have been crashing and our governments might have used our money to bail out the ones who crashed it, but at least we had SSDs. Quality of life aside, however, there must be some measurable benefit to SSDs, right? Something I can express in numbers, perhaps to the sound of Midnight Racer by backing track. I didn't spend a lot of time fine-tuning my graphics settings for this video. I wasn't looking for optimal results or to benchmark the RTX 5060, I just wanted it to look good, be playable, and fit within the limited VRAM. At 1440 normal with low RT and balanced DLSS, there was no VRAM warning in Resident Evil Requiem, and the game ran almost identically across both storage options, well within the margin of error. I don't want to say there was no benefit to the SSD. We've already discussed one big issue with hard drives that could be enough to sway you in the first place, but in terms of actual gun-toting survival horror gameplay, there doesn't seem to be a performance downside to the old spinning rust. I've been testing Death Stranding 2 for a min-spec versus max-spec video, which might come out before this one, I'm not sure as yet. Anyway, it actually looks pretty amazing even on the lower spec machine, and generally runs pretty well. So I'd been ready to say that it doesn't need much in the way of meaningful compromise to make it look good and run well. However, it turns out that this is one game where performance is actually affected by the storage. The SSD run beat the HDD run by 10% on average, and even more in 1% and 0.1% lows. The game also has a small stutter on every camera cut during its many long cinematics, but the hard drive saw a couple of stutters beyond that. Not quite as detrimental as RE Requiem's, but noticeable enough. I know I said this wouldn't be a 50-60 benchmarking video, but I took it as an opportunity to see if it could handle Crimson Desert with DLSS ray reconstruction. This game does have its fair share of graphical flaws, especially on lower end setups, and RR seems to fix a few of them, at the cost of a hell of a lot of performance. I saw an acceptable 30+ experience at hardware unboxed optimized settings, 1440p with DLSS performance and RR enabled, and as a result I saw a somewhat improved 0.1% low on the SSD, but overall slightly higher average and 1% lows on the hard drive. This could be simple run-to-run variance, or it might be related to those magically teleporting NPCs I mentioned earlier. Either way, I wouldn't really call it a win for the HDD. As it's an open-world online title, I expected there'd be a noticeable difference in performance in arc raiders. Textures and assets take a moment to load in on a new game with either media type, but the SSD recovers much more quickly than the HDD. Beyond that, if there were any major differences in draw distance or LODs, I didn't really notice them, and apart from my character occasionally taking too long to load in on the post-game screen, I didn't see any major downsides to the hard drive. Performance-wise, the HDD scored a little lower, especially in the 0.1%, but I don't think this is the end of the world. Well, okay, the game is clearly post-apocalyptic, but you know what I mean. Aside from the aforementioned catastrophic architecture failure, BG3 didn't experience much of a downside either. The 0.1% performance once more favours the SSD, but the difference is pretty minuscule, and this is all inside the city. Outside, where there's fewer NPCs milling around and less stuff for the system to do, it's gonna run a whole lot better. Lastly, I included Spider-Man 2 because it's a PS5 port, originally from Insomniac. In this and their previous game, Ratchet & Clank Rift Apart, the devs made a big deal about utilising the console's SSD, so I presumed there'd be a downside to downgrading to a spinning disk. Well, aside from the first run stutters I mentioned before, there didn't seem to be much loss in average performance. I found the GPU couldn't handle ray tracing at all, but at 1440 high with RT off and quality DLSS, both media types produce about the same average and minimum FPS, to within a few points of each other. It's just that the hard drive is more likely to stop for a breather while you're swinging around NYC, whereas the SSD is basically smooth sailing the whole way. Overall, these performance differences certainly don't justify the cost of the SSD. However, not only is raw FPS only one part of the story, This is also kind of a best case scenario for the hard drive. I bought myself a brand new drive for this video because while I do have a few old ones lying around, discs wear out and get slower and less reliable with time. There are slower spinning drives on the market at more appealing prices, and if you're not shopping for a hard drive but digging one out of the closet, or even just dealing with the same storage you've been using for 10 years, it might run even slower than we're seeing here. Meanwhile, this specific Gen 5 SSD might be 2.5 times more expensive, but there are cheaper drives that enjoy pretty much identical performance, at least for practical purposes. Yes, a Gen 4 might take a few seconds longer to load your save, but it'll still cut through the annoying problems caused by the hard drive's technical limitations, and at a smaller price premium. Also, it needs to be pointed out that I am using 32GB of RAM. Arguably overkill for gaming, yes, but if you want to play Sims, or multitask, or just have a ton of background processes running, 16GB might not always be enough. Once you run out of available system RAM, or indeed VRAM, Windows will start to allocate the stuff it can't find room for onto the page file, utilising your storage as virtual memory instead of the usual ultra-fast RAM sticks. Even the fastest SSDs will see some drop in performance, and using hard drives for page files is a disaster. I haven't actually tested this since back in the early days of my channel, and the video I made is kind of incoherent, but trust me, you don't want to play fast and loose with quality settings and background applications if there's a chance they might end up running on hard drive virtual RAM. It's painful stuff. Perhaps if you're a more patient person than I am, you're willing to overlook a few flaws in your computing experience to save $100, or you're looking to increase your blood pressure while using your PC, then choosing a hard drive over an SSD is a no-brainer decision for you. If you can find a good deal on a small SSD for your Windows installation, your page file, and perhaps one favourite game, pairing it with an HDD is probably the optimum experience, but a hard drive alone wouldn't be my choice in 2026. It just sucks that we're back in a position where this is even a question. Thanks to Asus for sponsoring the video. Check out Disk Copy and their other excellent utilities at the link below. Thanks for watching, kindly do the usual YouTube things if you feel so inclined, and I'll see you next time.